Hello friends, today I am discuss the super node and super mesh analysis. So first I am discuss for the super node analysis. Sometime a branch in a circuit has only a voltage source, then it is slightly differ to applied node analysis. In this case, we may apply super node technique. In this technique, the adjacent nodes are concerned by a voltage source and reduces to a single node, and then the KCL can be applied as usual. So better things we are getting for an example for the supernode analysis. So look at here. So simple diagram I'm getting for that. This one, this problem you have to calculate the current in 3 ohm resistance with the help of supernode analysis. Look at here, node 1, node 2 and node 3. So 3 node we have to consider. The voltage is V1, V2 and V3. We are getting the marking of V2 and V3, voltage V2 and V3. This is known as a supernode. Two node will be considered as a single voltage source. So now in this case we are applying for the supernode analysis. So look at here. So first node you have to making for node number 1. Look at here, 5 ampere current source is entering in node number 1, V1. So all of you know that KCL is summation total current is equal to 0 or incoming current is equal to the outgoing current. So look at here, 5 ampere current is entering in node number V1. So 5 ampere is equal to V1 minus 0 by 2. Next, V1 minus V2 by 1. So this is your equation number 1. Now next is your node 2 and node 3. Node 2 and node 3. V2 minus V2 minus V1 by 1. This one, when you have to consider for this one, that means this is the higher priority than the other node. So that's why here getting for the V1 minus V2 minus of V1 by 1. Then V2 minus 0 by 2. This one. Next here V3 minus of 10 by 3. V3 minus of these voltage source is 10. So V3 minus of 10 by 3. Then after your V3 minus 0 by 2. This is equal to 0. No current source is getting here. So that's why this the total current is equal to 0. So this is the equation number is your 2. Now next things is your V2 and V3. So V2 minus of V3 is equal to 20. So why not is your V3 minus of V2 is 20? Because your this V2 is a higher potential and V3 is a lower potential. That's why it is the V2 minus of V3 is equal to 20. So this is the equation number is 3. So you have to solve the equation number 1, 2 and 3. Then you got the value of V1, V2 and V3. So then automatically you have to find the current through the 3 ohm resistance. So current through the 3 ohm resistance is equal to 2 by 3. So this is your answer, 0.6667 ampere. So this is for the super node analysis. Next we have to consider for the super mesh analysis. Look at here. Find the current through the 5 ohm resistance using the super mesh analysis. Now we are getting two mesh will be considered as a single time. Look at here. So here this is one mesh, this is the another mesh, and this is the another mesh. So be careful here. If you consider for this is your mesh 2 and this is your mesh 3, so one common source is getting, this is the current source is getting here. So now we are getting for the considered node source mesh number 1 and mesh number 2 a single mesh. Okay, so now how to solve this type of problem? So look at here. So one by one I'm getting discuss. Okay, so first you have to consider for this one. Look at here, this one, follow my pen, this one. This mesh current is your I1, and this your mesh current is your I2, and this is your mesh current is your I3. So three current I1, I2 and I3 I have to already mention here. So 50 volt source, this one 50 volt source. Then here if you consider for your this mesh, then here current is your here I1 and I2 is your outgoing upward and I1 is your downward. So that means your 10 into I1 minus of I2. This mesh you have to consider. So that's why this is your higher priority. So that's why I mention here getting for the I1 minus I2. Next is here downward, I1 is downward, here I3 is your upward. So 5 into I1 minus of I3. So if you solve this problem, solve this equation, so 50 into I1 10 plus 5 minus of I2 into 10 minus of I3 into 5. Now if you solve this equation, so this equation will become equation number 1. Next, we are considering for the mesh equation mesh 2 and mesh 3. Look at the diagram, this one. Here no source is getting here, so this so that's why the right hand side is equal to 0. So look at here, 2 into I2 plus 3 into I3 into 1, I3 into 1, I3 into 1. Then here 5 into here, then this mesh is your concern, so that's why this mesh current is your higher priority. So I3 minus of I1, I3 minus of I1 plus 10 into here I2 minus of I1, I2 minus of I1. If you solve this equation, you got this equation number. Here equation number is 2. Second things, look at here. Here here current direction of the then this one. Okay, and your direction of the current is here I2, and here direction of the current is here I3. Okay, so that means this value is your 2 ampere. This value ampere is a 2 ampere. So look at here, direction of the current 2 ampere and direction of the current is here I2, both are the same direction, and direction of the current is of I3, this is for the opposite direction of that. So that's why resultant of the current of I2 minus of I3, this is equal to 2 ampere. So this is equation 1, 2 and 3 already find out. So if you solve equation 1, 2 and 3, then I1, I2 and I3 is find out. If I1, I2 and I3 is find out, then the current through the 5 ohm resistance, I1 is known, I3 is known. So resultant current of 5 ampere, so I1 minus of I3. So you have to calculate and you have to find the result. Okay, so I think your today discussion of your super node and super mesh analysis, all of you clear. If you not clear, then comment on the comment section. So all the guy have to subscribe my channel, and if any doubt regarding this topic, then comment on that. Thank you. Bye.